Hello everyone and welcome to our 18th lecture, Trig, Identities and Equations. So last time we covered the unit circle and this time we're going with the formulas. Let's start off with the most important ones. If there's anything you should remember from this video, it's the following two. The first one is Sine law. For this we have to go back and remember when I said that technically the side in a triangle is proportional to the angle opposite to it. So here's the triangle we're working with. I went ahead and also drew the altitude from the angle alpha. Altitude is marked as h, sometimes referred to as height as well. It is a line that is perpendicular, or at 90 degrees, to one of the sides and connects the vertex, which is another name for the corner point, on the opposite side of the side, so in the angle. I drew that like on the picture because this way we will get two right triangles from basically any triangle we work with. Because trigonometric functions only work in right triangles, right? Well, yes, but no. They're defined for right triangles, but they can be used anywhere if you add some corrections. And by separating the non-right triangle into two right ones, we can easily use them to get some new formulas with those set corrections. So in our case, we will be working with gamma, beta, b, c, and h. B and C are hypotenuses to their respective triangles. H will always be the opposite side to the angles, so this means we can use sine, since the opposite over hypotenuse. So let's write down both formulas. So gamma looks a bit ungrateful, just like alpha, because on PowerPoint it looked similar. So A and alpha look similar, just like gamma and Y do. But if you see them side by side, it's easier to determine which is which. Now that we have written them out, we can see that something happens in both formulas at the same time. It is the newly introduced height. So what if we isolate it in both, then equal them? Like so. B times sine gamma equals C times sine beta. We get this. Well, this is one of the formulas I really like because it's easy comparison between two sides and how a change in one responds in the other. We will see this also in electricity and circuits. I think transformators have this formula and a lot of other formulas in physics, so do not worry about this. These beautiful formulas like this, so like A times something of B equals B times something of A, all over the place in physics. Don't worry about it. Amazing, you're gonna love them. Anyway, now since gamma is kind of connected to C, let's have them both on the same side. Same for beta and B. So we will divide with both sides. So divide by sine gamma, and then divide by sine beta. We get this. This is the ratio between a side and the sine of the angle opposite to it. And it is equal to the ratio of another side in the same triangle over the angle opposite to that side. But does this work for these two sides only? Well, no. It's for all sides. If you want, you can also do another height, and then the same process. Sure, the heights are different, but the ratios will be the same for other two angles and sides as long as you're in the same triangle. And if you do all three different connections, so for each angle 1, you're gonna get all three possible connections between the sides and the angles. And in such a system with multiple equations which equals like b over sine beta and c over sine gamma, if I had b over sine beta equals a over sine alpha, we could equal all three of them in one formula, and we would get something like this. And this is our sine law, if you haven't figured out from the name. It can be used in any triangle. The best part is, even if a shape isn't a triangle, it works. Well, only if it can be divided into triangles, or that if you can find such a triangle that where you would have enough information, so two sides and an angle, or two angles and a side, so you could use this formula. For instance, hexagons. Lovely shapes. You get like, what, 6 triangles in it? Beautiful. Now for the cosine law. Just like before, this is the second important formula I kind of want you to know after this video. You can ignore the rest of it, I just want you to know these two. Oh, I see the screen is kind of cut off. Now you should be able to see this guy. Okay, perfect. I apologize for this. But yes, here I separated the a side into x and a minus x. So this point is that the one that separates a into two parts. Next, we will use Pythagorean theorem for both right triangles. instead of the sine law. So we get x squared plus h squared is b squared, and then a minus x squared plus h squared is c squared. Now let's solve this bracket, because we don't like squares of differences. We can write them out into a trinomial. I think that's the right word, I forgot. Like this. So first one squared minus 2 first second plus last one squared. Now that we broke this apart, we can insert this back into our second formula. And while we're at it, let's isolate h squared in the first one and then put that in the second formula as well, because if we do something in math, it is that we combine our equations. So like this, I isolate h squared and I get b squared minus x squared. I put this in here, so we have the opened bracket plus the h squared which remained equals c squared. Now I will recolor it back into white and order it around, so it starts at c squared equals something. We see that x squares will cancel out, and we can reposition these like so. We get a squared minus 2ax plus b squared, but if we can put this minus 2ax at the end for one single purpose, because x can be defined by several other formulas. For instance, a minus x gives us x, or trigonometric function. X is cosine of gamma times b, because cosine is adjacent divided by hypotenuse. And if we use this formula for x, so b times cosine of gamma, put it in here, we get c squared equals a squared plus b squared minus 2ab times cosine of gamma. So essentially it's a Pythagorean theorem at the start, and then you subtract the correction for the angle. Sure, this probably has some visual and graphical explanation. To be honest, I forgot to find it, and yes. But this derivation kind of works, and I guess it's kind of clear and easy to make if you're running low on time and forgot the formula. But yes, this is the second formula which I kind of want you to know today. And yes, there are other laws like tangent, cotangent, and I think even secant law. You will see what this in a second. They do get more complicated and less commonly used, so I think the two I covered are the most important and enough for you to use anytime you want to. So let's continue with trigonometric identity. For that we need our unit circle again. Then we'll take a random point on the circumference and determine its coordinates as x and y. Now we will write the Pythagorean theorem for the length of the hypotenuse. So x squared plus y squared equals h squared, so hypotenuse. But in our unit circle, the hypotenuse length is equal to 1, so let's substitute that in. 1 squared is 1. Now, if we had an r in the formula instead of h, we could get so that would be the formula for a circle, which you may remember from like conic sections. We didn't make a lesson, but you probably covered it in schools. It's when you have a cone and cut across it with a straight plane, and depending on the angle under which you cut it, you can get a circle, ellipse, parabola, and hyperbole, I don't know the words. These are called second degree equations. But they aren't as important to us in this specific lesson, it was just a loss of focus. Now that I have uncut this, because for some reason it cut my PowerPoint, we have this formula for this triangle here. Now we can substitute the cosine of theta and sine of theta instead of the coordinates, and we get this formula. This is our first trigonometric identity. If we take sine and cosine of any value, so the same value, square those sine or cosine results, then add them together, we will always get 1. If you don't believe me, check Desmos. There you can insert the formula cosine of x squared plus sine of x squared, and it will draw a horizontal line at y equals 1. Anyway, since we have our first equation, we can do more with it. From last time, we know that there's a simple connection between all 4 main trigonometric functions, and by simple I mean just multiplication and division. The tangent of theta equaling to sine of theta over cosine of theta is one of them, so let's try to divide and see if we get anything useful. So I will divide by cosine of theta squared, and I will get 1 plus tangent of theta squared equals 1 over cosine theta squared. But there's another name for this result, so 1 over cosine theta squared. It's called a secant. It is marked as sec theta, like so. Yes, I did just notice that I put the squares on the wrong place. Frankly, I don't think it matters as long as you know what you're squaring and you get the right result. And my teachers never complicate it if we proceeded to solve it correctly later. But this is the more correct way of writing. So you square the function, aka the result you get when you put in theta. But yes, this is another function. I have mentioned it before and I will show it later on an image, so you will see what it is. Don't worry, we're not gonna go deeper into what it is, because frankly, even I barely ever run into it. As for the next property, because we already got the second identity, we can divide by sine squared, because cotangent is cosine divided by sine. So we divide by sine squared and we get cotangent of theta plus 1, cotangent squared of theta plus 1 equals cosecant squared of theta. And this is our third identity. You can also just write 1 over sine squared theta. I don't mind. It's just a formula that I'm presenting to you because we won't be real. I mean, the default identity sure may happen to appear in some formulas eventually down the line. The other two, don't worry, we're more likely not to run into them. Now, these are our main three identities that you are likely to encounter in math. The first one, so the cosine squared plus sine squared is 1, is generally more common than the other two. Depends on how deep you go into math. Don't worry about it appearing too often though. But yes, the other two are essentially the same one, just used to work with tangent and cotangent in formulas. Next are complementary angles. Now you may be wondering, what is that? Well, basically two neighboring angles, which in this case add up to 90. So alpha plus theta is 90 degrees. And what is interesting about them, and it's another property of these functions which we may work with eventually, is that, let's rewrite 90 degrees minus theta as alpha. We see that the adjacent side to the angle changes from theta being x-axis to alpha having it as y-axis, meaning that sine of theta is the y-coordinate, but that same y-coordinate is cosine of alpha. Why? Because cosine is adjacent divided by hypotenuse. In this case, it's the y-axis divided by the hypotenuse, which is 1. While cosine of theta is x-axis for theta, and for alpha x-axis would be sine of alpha. Why? Because it's the opposite side of it. You see? The theta, it's adjacent. This length is the same because this is a square, or, well, even if it was a rectangle, the opposite two sides would be the same length. This one looks more like a square, which is a poor illustration, but if let's say the point was up here, these two lengths here and here would be the same, so adjacent, so cosine of theta would be the same as the opposite, so sine of alpha. And we can write this down here. Sine of alpha is cosine of theta, and cosine of alpha is sine of theta. This also works for tangent and cotangent because, well, the length goes down to x for tangent and up to y for cotangent. And here is the imagery in which you can see how they work, because I haven't told you how cotangent works. Also, here's the cosecant and secant visualized. So yeah, this is kind of a all-inclusive graph from Stack Math Exchange, which is a wonderful website which explains this. So yeah, cotangent goes up to intersect with y-axis, tangent goes to intersect with x-axis. Then this is 90 minus theta, and it switches the properties. So basically, always pay attention, just like in the first lesson of trigonometry I said, pay attention to which side is the opposite to the angle and which one is adjacent, because one that is adjacent to one angle will not be adjacent to the other necessarily. Our next property is angle sum and difference. So for this one, we will get this visually on our unit circle. Our point P is described by alpha, while our point Q by a certain beta angle greater than alpha. So we can write this out as the angle for P is alpha and the angle for Q is alpha plus beta. So here we write out the coordinates for the points P and Q. So P is at cosine alpha and sine alpha, while our q is for cosine of alpha plus beta, so all the way up here, and sine alpha plus beta as our y-coordinate. Now, next steps would involve vectors and everything that we haven't covered yet, so I will skip them and get to the formula and explain it on an example, because getting the formula would be a pain in the ass if we haven't covered the basics of vectors, and this is a whole ass new video. Let's take alpha as 30 and beta as 30, giving us the sum of 60. We know that sine of 60 degrees is a square root of 3 halves. Now for sine and cosine of 30 degrees, it's a half and a square root of 3 halves. The formula for sum and difference of angles in sine is as follows. Sine of sum is a sine of alpha times cosine of beta plus cosine of alpha times sine of beta. This formula accounts for vectoral transformations, or more accurately, rotations in this case. So let's use these values in our example and see if it's right. I plug in the angles and I replace them with the values. Now on the right side we can first multiply the fractions and then add them together, or we can see that we are adding two of the same terms, which we have to note that it is unique for this example because alpha and beta are the same. If they were different, we would have to multiply and then add. So yeah, this basically cancels out the half because 1/2 is in both terms and there's just 2 times, so 2 times 1/2 cancels out and we get square root of 3 halves, which is our result. So our formula for sine of a sum or a difference of angles is as follows. Here I marked a plus minus sign. In reality, you do it something like how I did it in lessons before, like quadratic formula. So plus above, minus under. But here the plus minus are on both sides, which means that if we are using a plus on one side, we must use the plus on the other. Or more accurately, if we're using the top symbol, the top sign in one, we have to use the top sign in the other as well. Why is this important? Because in the next ones, next formulas, this may change. Like this. So here's the formula for cosine. We see that we take the cosine of alpha times cosine of beta, and then we have a minus plus here. So if we use plus in the brackets at the start, we have to use minus in the formula. And then we have sine of alpha and sine of beta. I colored these orange and blue. Orange represents the top and blue represents the bottom. So if we're using the orange one, you have to stay consistent with the color usage. This all again comes from vectors, which we don't have enough knowledge and time to understand yet. Here's the formula for tangent. Here we have 3 of such symbols. 2 are plus minuses and 1 is a minus plus. So if we have alpha plus beta, we have tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. And the other way around. Now here are the double angle formulas. We just used the previous ones and used theta for both alpha and beta, giving us the following formulas. Of course, you can use the squared identity on the cosine to get 2 more, but I won't flood you with formulas, so you can do those as a homework for today. If I had to order them by importance, they would definitely go as I'm presenting them, starting with the most important, and every next one is much, much less important, because most people won't make it this far into the video. If you're still here, comment down below tangerine, just so I can see how many people are actually interested in this off-topic stuff. But yes, I would put these formulas as still appearing every once in a while, or helpful to know when solving stuff, because you're gonna run into them sometimes. Now for next, formulas, these are half-angle formulas. They're plain weird. Frankly, I think I've used either of the formulas once max in my life. They're mostly a honorable mention, as they kind of fit in the topic but are very unlikely to be required on a basic level. You don't have to memorize them. I just took the list from this website because, well, they made it and it's nice for presenting. And this helps me point the people that are actually interested in learning them in the right direction. So if you want, here is the website from which I took these, so I'm pretty sure they explain it a lot better than I possibly could. And this would conclude our lesson for today. God, this is actually a short one, that's crazy. Here is the mini test. I made it easy. You just have to remember the table from the last time and that's it. But yeah, thank you so much for tuning in today. I hope the mini test solving goes well. Oh, just some news. I forgot to post the video last week because I didn't have time. I had some presentations in university and everything. I'm gonna try to get back on schedule with shorter science or math in Minecraft, or simplified ways, like a 3-minute explanation of some concept in maths or something. That will continue from next week. And I also have a plan for a video, as you probably saw the poll on my channel. Should I make like philosophizing, debating video where I play Minecraft and just like the philosophies on positive affirmations and everything, how basically helping people that feel lost in life? Because I feel like at this point, in this day and age, everyone kind of feels lost, and I have some mentality that has helped me. I can't promise it will help everyone, but if you want me to make that video, if you want to see it, obviously tell me in the comments. I am very engaged with anyone that comments. I thank you for any feedback, suggestions, and whatnot. But yeah, hopefully mini test went well. Hopefully you remembered something from the lesson, and I'll see you all on our next quest. Bye!